Yeah, so hello, my name's Mark Allen. I'm very happy to be here with you today. As Ben mentioned, I do work on Logger and curl, and I just started a new project too called AWS Beam. I didn't start it, I inherited it, took it over, and it's about trying to get first-class Amazon client support for Erlang, and Elixir too, actually. So if you're interested in that, please get in touch with me, because I'm always looking for help on that. So what I want to talk about today is running a package service behind your firewall, and we're going to kind of explore some of the intricacies and the messy details that can make this work. Now, I'm the first person to admit that this is 100% hack. It is essentially subverting and manipulating the machinery of Rebar 3 to my own nefarious purposes. And there is a actual, I don't know, it's probably about 50, 55, 60 lines of Erlang that I added to Rebar, mostly to process the alternate registry file. But we'll get into that later on down the road here. So of the people in the room here, how many of you know what hex is already? All right, cool. So we'll just skip the first slide. Let's move into the motivation for the talk. So first of all, I just wanted to tell you that for the last 2 years, I've kind of been having daydreams about doing this. We have a very extensive Erlang packaging system inside of our company, and it's all hosted on enterprise GitHub. And that's fine for what it is, but what I'd really like to do is to be able to move all of those build artifacts into a place where they can be securely published and managed and vendored and just sort of generally taken care of in a way that is not super great inside of a GitHub environment. In terms of building projects and getting repeatable builds and all those sorts of things, it's perfectly adequate for that. So just to cover some of the other reasons why I've been thinking about this problem is, I'm sure I'm not the only person in the room that has this issue where we have a lot of open source software over here on this side, right, that comes out of Hex, the public internet-facing Hex. And then we also have like our own special sauce code that we don't want to publish to the internet. And we need to take some pains about how we're going to control and manage access to that code, right? It's not code that we necessarily want to have published on the internet, even if it were in a way that was somewhat secure, right? So that's one reason we have proprietary code. The next one is that we want to manage our forks, right? So we have some open source library. We've patched it or modified it for our special environment, and we want to be able to include it in our builds. We want to control, right? We want to control all the things around that, how often it gets updated. Another reason is that maybe you have an application stack, like inside of Alert Logic where I work. We have a web stack that's composed of a bunch of proprietary software. It'd be great if we could package all that up into hex-style packages and manage it like that. And then finally, there's sort of this speed and politeness argument, which is to say, if you have an office that has crappy internet, or you have an office that is pulling like giant globs of data from Hex or from the Fastly CDN, maybe you want to cache that locally. Maybe you want to set up your own sort of local cache for that inside of your environment, inside of your firewall environment. So those are some of the motivations why I've been thinking about this problem and why I'm interested in trying to solve this problem. So a couple of people have heard the sort of elevator pitch, which I just went over in the slide, and said, well, why don't you just host Hex, right? Like Hex is open source, you can set it up. It's not that hard, so just do it. And my response to that is that there's just a lot of infrastructure that I don't really want to manage. That's the primary reason. The fact is that I'm super lazy, and there's just a lot of infrastructure with Hex that I don't want to have to take care of. There's also some superfluous functions that I don't really care about as much. And I don't want to have to worry about those in this context either. So I was thinking about having something that was just really simple, right? Very simple to deploy and simple to manage, something that wouldn't be a headache, right? It wouldn't be too difficult to set up and to keep running. I know we're all super busy, so Another question I get about this problem is, doesn't Hex already support private repos? It does in sort of a notional way. Like there's sort of in the design specs this idea that Hex could support private repositories, especially in the version 2 registry specifications. We're going to kind of talk about how registry stuff works later on in the talk, but as far as I'm aware, none of that's really been coded up. And in any case, I think there's still a pretty significant political problem with management around how you want to deploy your secret sauce code out onto the internet, right? Like even if it's encrypted or has strict access control, I can see that sort of non-technical managers or even technical managers would be very, let's call it nervous about deploying your code out into a public internet-facing service. As I mentioned on the slide, what could possibly go wrong? I think we can all think of scenarios where that doesn't work very well. Well, I've already mentioned this before. The final sort of objection that I usually hear about this is that you should just use GitHub. Well, I mean, we do. We are using GitHub right now. That's fine. As I mentioned, it does work. It works reasonably well, but you're signing up for sort of a set of assumptions when you use that model, and they're not always great. And I think people that have come from a background or are currently working with Go as a language can tell you some real horror stories about relying on GitHub as a version control system for your dependencies. You are tying yourself and you're tying your build sort of to the mercy of some third party that you do not necessarily control. And as long as you're cool with that, and that's fine, right? But you're buying that. If you say just use GitHub, that's part and parcel of what you're signing up for. That makes a lot of people nervous. It makes me especially nervous, something that I'm not especially interested in doing. That's why yet another reason why I've been interested in trying to address this issue. So what are the design goals? When I started out with this daydream, what were some of the goals that I had in mind for what I wanted to do with this project? The first one was, as I already mentioned, was that I want it to be simple, and I want it to be simple to integrate with cloud services. So in other words, I really want this to be so easy that I can actually sort of abstract away most of the infrastructure and just leave it up to, for example, Amazon. Right? I can put all my packages in S3. I can run all the endpoints off of an API endpoint service that Amazon provides to me. It'll get routed into a little function that runs in their serverless environment called Lambda. And I also didn't want to change rebar 3. That was an important thing. It ended up being really important that I had to change rebar 3 because reasons. We'll get into those reasons, promise. But there were minimal changes, so almost no changes, as I said, about 60 lines. So the proof of concept server that I wrote for this is actually a Python script. It's not Erlang at all. It's a bottle. It's a little bottle script. Bottle is a web framework for Python that implements RESTful endpoints very quickly and easily. And I figured that would be a good proof of concept for how easy and simple this could be, right? I don't want to have sort of the overhead of actually having to compile an Erlang beam and ship it up somewhere and all that. As I mentioned, I want it to be really sort of very lightweight, super minimal infrastructure requirements. So it's written in Python. Yeah, really, it's written in Python. Why? A couple of the reasons I already mentioned is that Python has great library support. It's also easy to write a web server, so those are two good reasons. But the final thing that sort of unlocked this potential was that there's a library that I found on PyPy, also called the cheese shop sometimes by people, that is the Python package repository. And it is from Machine Zone, who are some of our Erlang friends, I guess our erstwhile Erlang friends these days. But anyway, they have a Python library called ErlTerms, and ErlTerms can evaluate a file consult style file and turn it into Python data structure, which is pretty cool. It actually treats the file from Erlang as sort of just a regular old, well, they wrote a parser, is really what they did. They wrote a parser that turns the file consult style syntax into Python data structures. And that was sort of the missing, or the key that sort of unlocked all of this potential here. So that was the final thing that I needed to make this work in Python. If I had not been able to make this work in Python, then my fallback was to just write a simple little cowboy server and go with that. But anyway, it's in Python. So let's talk about rebar 3. I assume you all use rebar 3. Is there anyone here that does not use rebar 3? Yes, let the record reflect there's no hands. So I did recently give a talk about rebar 3. It's on YouTube. I think it's pretty good, and you know, it wouldn't be bad to watch it. So the link's in the video here. But the important part about rebar is that it has this plugin system. And the thing that you may not realize about rebar is that actually nearly every command in rebar is a plugin. So what that means is that you can hijack them, you can change them, and make them do different things than what they were intended to do. And so I want to talk about a couple of those plugins right now. These are the built-ins that come out of the box. There's actually two that are really important to this particular discussion. The first one is this rebar priv update. That's the command where if you type rebar 3 update, it goes to hex and it fetches down a serialized ets table, and then it unpacks that and does a fold over the top of it and inserts records that match the filter that it applies into another ets table, which it serializes and uses as its local cache. And then the final thing, the other plugin that I wanted to mention in the talk here was this thing called rebar package resource. And there's actually a bunch of different package resources in rebar 3. There's one for each type of downloadable resource. So for example, there's one for Git, there's one for Mercurial, there's one for Hex. But it's really the Hex one that's important for this particular talk. So let's talk about how rebar uses the Hex package indices. First of all, you should know that Hex publishes a whole bunch of different indices. The version that is important for this discussion is the sort of version 1, or the initial version package index. The resource indexes are, the index resources are fully documented, which is really nice. But even if they weren't fully documented, it's easy enough to just take the serialized S table and start an Erlang system and load it using a file to tab. And that works super well, actually. If you just want to explore what's in this repository. But to cut a long story long, the way that it works is that there's a sort of a set of keys, and the keys are of two flavors. One is sort of the naked package name that you're interested in. For example, I have a Saga project called Gisela that I talked about last summer. And if you look that up in this package index, what you will find is that there's two versions that I've published to a Hex for this particular project. And then you can actually go and look up the specifics of each entry in that list by adding the version as a tuple. So it's all binary strings. So basically you have a tuple of the application name and a version string that's supposed to be a semantic versioning, because that's the Hex standard. In practice, it actually ends up being kind of like whatever crap you throw into your app.source file. But the Hex standard is that it's supposed to be some kind of semantic versioning process. And those two things are the way that rebar understands and holds local cache for all the packages that it knows about from Hex. So every time you tell rebar to fetch a Hex package, it looks up the data that it needs to get to download all that stuff from this ets table that's sitting on your disk, that's sitting on your SSD or whatever. And so that's sort of going to be my vector of attack on this particular project. I just wanted to show you the registry here. I don't know, can you read that all the way in the back? Is it too small? Yeah, it's too small. All right, well, sorry about that. I'll try to make it larger next time. So what this is actually from the hex.pm specifications repository, and this is out on GitHub. You can go look it up or whatever. But what this does is it has all the fields in the sort of upstream resource. This is not the this is not the data that rebar uses internally. This is sort of the source of the data that rebar uses internally. Okay, so just to be really clear about it, this data comes from Hex. It comes down to your local system. Rebar does a fold over the top of this ets table, okay, because this is a serialized ets table, and then it creates a new ets table and then serializes that and puts it on your disk. That's what it puts on the disk the second time is its local cache that it uses to look up stuff in the future. So you can see that there's quite a number of good things here. Both the package and the version list stuff is there, right? That's important. And then there's also the package and version key that I mentioned earlier with all of its dependencies, a checksum, right, which is just to ensure integrity, and then the build tool, which is to say, like, what thing packaged this for Hex, right? Did it come from a make file? Did it come from Mix? Did it come from rebar? What created it? And we're gonna get into that a little bit too. Now, I don't know if you could see at the very top of that message, but it said that this version is deprecated. So why is rebar 3 still using it? It's a really good question, and I didn't know the answer to this question until I asked in IRC, which is like Slack for old people. And what I found out is that the reason is because the version 2 specification, which is not deprecated, uses protobufs. And protobufs, as they get deserialized, currently go to maps. And so that means that the OTP that you build rebar 3 on top of has to have map support, really, to enable you to exploit these registry specifications. And they're also organized differently than the version 1. So there's sort of a data model mismatch, and there's also a map problem. It's not really a problem. I guess I should say it's a map opportunity. So that when we can finally at last sort of drop the OTP releases that don't support maps, which hopefully will be this summer, then we can move forward with implementing this version 2 specification inside of rebar 3. But the net of this is that when I proposed initially that I was going to hack rebar 3 to subvert it and download my own stuff, the reaction to that was pretty swift and pretty negative. And I got to say, I'm sympathetic to that. So my next plan of attack was, oh, well, here's this new thing. I'm going to figure out how to make that work. But there's just a lot of confuse and much sad. And it is figured out now. I actually have at the end of the slide deck, I have a link to a gist that I have that tells you how to consume these resources from Erlang. But as I mentioned, the map support stuff has sort of been a blocker on terms of moving forward with this in a significant way. I'm hoping that we'll get time to work on that soon. Anyway, the short version of this is that it's awkward. It's very awkward. So we're still using the version 1, and we will continue to use version 1 for some amount of months to come. All right, so let's talk about this stuff that's on disk. So I've already made it clear that rebar folds over the top of the upstream data source and stores it. Where does it store it at? Well, it stores it in this directory called $home, which is your home directory, .cache, /rebar3 hex default. And then there's 2 files in there. One is registry, which is the upstream source, right? That comes from Hex. And then there's this packages.idx thing. That's the folded over customized version that rebar has created for itself. And then when you ask rebar to look up dependencies, it just instantiates an ets table from that serialized ets table, packages.idx. And as I mentioned earlier, you can explore this yourself if you want. You can use ets and file the tab. It's pretty cool. So at this point, it seems clear that the way that we can make this work is pretty straightforward, right? So what we want to do is this. We want to subvert the package index, right? What I want to do is I want to inject my own stuff into that index. I want to inject my own data, I want to overwrite the hex data with my own. Okay, with my own versions and my own names and my own applications and all that stuff. And so what I did is I modified rebar to expect either a serialized ets table from the endpoint. Actually, this should be not either, but and. It tries to download both the serialized ets table and also an auxiliary JSON document from a different endpoint. So the cache contents, as it says at the bottom, derives all the decisions about how this works, right? So let's talk about the hex package format, because I think that's really relevant. That's where a lot of the metadata for this comes from. This is the current format right here. It's a tarball that's created, again, by another plugin. This is actually a separate third-party plugin. I mean, it was written by Tristan, who helped to write most of Rebar. But it's still a third-party thing. It doesn't ship out of the box. You have to add it yourself. But the artifact is a tarball. The tarball has a version, a file literally named version, just like this, in all uppercase, screamy cap. And it's a digit. Last time I checked, it was 3. I don't know why it's 3, but it is. Then there's a metadata config file. This is in file consult format. This is where that Python library comes in. And then there's the actual contents. So this is like a tar of all of the files that Rebar thinks are important to your project. It excludes things like swap files for Vim and build artifacts from C things and all sorts of other things. But it puts them all into this file, which it compresses and stores into another tarball. And then there's the checksum file. And the checksum file is created by concatenating the 3 previous things that I mentioned, smashing them all together, and then doing SHA-256 on the top of them and emitting that as a hex value. That's the contents of this checksum file. And if you click the link on the slide, you will see the upstream specification for the tarball as well as the implementation. So that's the first and second links on this slide here. All right, so now we know how we're going to inject our own data. And we know what kind of data we can inject, right? We're going to create these tarballs. We don't have to change that at all. We're just going to reuse all of that. So what endpoints do we need to implement now in Bottle or in whatever server we want? So these are the endpoints that I need to be able to support. The first one is a get endpoint. And these are all sort of relative URLs, right? So these would be your server name / blah, blah, blah. So the first one is the get registry.ets.gz. That comes from upstream. You can just curl that right off of hex.pm. And you can also control that. Like you can change that whenever you want to, or right? You can manage that just as easily as you can manage any other resource that you might have to this whole process. The next thing is this registry.json. This is not an official endpoint. This is a hack. This is part of my hack. But I added this because it seemed like a natural thing to do. And what this is a JSON format that essentially has the same data as the ets table, but just presented in a JSON way, which is to say that it has a key and a value. And the key is either version or package, and the values of those are JSON data structures, which mimic the ets tables, right? So there's that. Then I also need to have a way to get the tarballs that get created. So that's the third endpoint here, the get tarballs package-version. And then finally, I need a way to upload new stuff, right? I need a way to release new releases. And in Hex, that is done with a post to this URL called packages, and then the name of your application, and then releases. And the body of that post is the tarball, right? There's also a custom content type, which I didn't get into here, but Hex expects a custom content type for this particular payload. My bottle script is not that finicky, but if you want to have sort of parity with Hex behavior, then maybe that's something that you're interested in and pulling together here. So let's pull all the pieces together. So I have a lightly modified Rebar 3. Rebar supports a environment variable called hex-cdn. What hex-cdn does is it actually sets the host name for almost all of those endpoints. The only endpoint that it doesn't automatically handle is the API. So there's kind of 2 different endpoints for Hex. One is focused on these resources that we've been talking about, and the other URL is focused on this API. So if I just go back a slide really quick, the top 3 endpoints, all of these get endpoints, you can think of those as sort of read-only, right? Those come from hex-cdn. And then the fourth endpoint, the one where we actually upload stuff, that goes to a different endpoint. Okay, there's a different part of Hex that deals with rights. Okay, and so what I did in my hack is I just changed. I have a new environment variable such that when I change the hex CDN, I can also change the hex API endpoint. And then I have a Python script that implements all of these endpoints here, and then that's it. That's pretty much how all this works. Given that this solves the problem, kind of like what's next, what are we going to do about all this? As I mentioned, I think upstream is -1 on this, and I don't think that's the wrong thing to decide about this hack. It is terribly convenient for the moment that this does work, but there needs to be a better solution to that. As I tell my 9-year-old quite frequently, just because you can do something doesn't mean you should do it, and I think that applies in this case. So I guess I will say don't always follow my example. Sometimes I have not good ideas, but they do work. So there's that. And then I guess I wanted to sort of close out this discussion about how do you want to solve this problem the right way. And as far as I'm concerned, the right way to solve this is to implement the V2 stuff, and then we'll be able to expand the CDN environment variable. Right now, it assumes that you have only one server. That needs to be like a list of servers, right? And what we need to do is pull resources from all the servers in that list, right? It may be a list of one. If it's a list of one, that's quite simple. But if we have a whole bunch of servers in that list, then we'll pull all these resources and then overlay them on top of one another, such that we'll have a nice materialized view of all the different sources for where data's come from and where it can go to, right? But basically, we want to use the same idea, right? We want to have this materialized view of all these different resources cached on my local workstation and available for use throughout my entire enterprise, right? And so that's the basic idea. Here's some resources that I have for the talk. The first one is Charm. This is the bottle. This is the bottle and some of the Python stuff that I've been working on. It's kind of a hot mess. I will be totally honest with you guys. I was hoping to have it a little cleaner by the time of the talk, but it's not terribly clean right now, sorry. The second is the hex specification URL repo. This is a really great resource if you're looking to sort of hack your own hex stuff. It's fully documented, it's really helpful. And actually there's also a rebar channel on IRC. If you have questions or concerns or problems or whatever, you can pop in there and ask questions. So that's pretty cool. The third thing is this gist that I wrote. This describes how to decode the hex v2 resources. This took me a really long time to figure out, actually. Even though the resources are fully documented, it's sort of left as an exercise to the reader to figure out how to implement a decoding stuff. So this is one way that you can do that. I presume there are others, and actually this gist is not that great of Erlang. It's just some stuff that I threw together that works. I mean, a production version of this is going to be better, for sure. And then finally, the last resource here is the Rebar 3 Hex plugin itself. That's really helpful and useful. That's the plugin that helps build those tarball payloads. So I do have a final plea for the talk here, and that's to please consider putting your libraries on Hex if you're not already doing it. One of the reasons that I think Erlang as a community is behind a little bit sometimes is that we haven't been that great about publicizing when we have really good libraries for things and have good solutions for things. And the reason for that is because a lot of those libraries are distributed kind of all over the place, right? And with a resource like Hex at our disposal, we can kind of centralize all that stuff in one place, and we can start getting a sense for what's popular and what's not popular and what people like and what people don't like. And it makes your project visible. That's important. Don't underestimate that, because it is something that people look for when they're considering platforms to build solutions on top of. It's easy. It's really easy to get started with Hex. So if you're not already doing it, please consider And then it's free, right? You don't have to pay anything. And Fastly has been kind enough to give the Erlang community and the Elixir community a CDN access. So we have points of presence literally all over the world serving hex data, which is really great. So that's my whole talk. I have about 5 minutes left for questions or comments or concerns. But thank you for letting me talk to you today, and I'm happy to answer anything. Thanks.
So, small bit of updates for the tarball handling. Currently, the people working on Hex are working on an application called hex_tarball that is about handling all of that in the same manner for mix and rebar 3.
Okay.
So there's ongoing version with that that should make some of that go easier.
Okay.
And in your call to action, I would like to add calling rebar 3 hex docs as you publish your packages, because that also uploads the edoc documentation.
Okay.
The hex.pm doc site, where currently I think most of the Erlang community does nothing about that, but all the infrastructure is in place to do it.
Okay. So thanks, Fred. That's a good update. I'll be honest. I didn't know that plugin existed, so that's why I haven't used it.
Started last week.
Oh, Fred said it started last week. So, all right. So it's pretty new. But anyway, great. Are there any other questions or comments? No.
Thanks a lot.
All right. Thank you. Appreciate it. Thanks.